Hello and welcome to Meclan 360. In this video, I want to explain to you how to resolve a force into components. Now, I have done a video on the parallelogram law where you can only find the resultant force or probably other forces, but it is limited to only two force systems and maybe maximum three forces. But with this one, we want to look at how to resolve a given force into x and y components. However, we will look at a special case where we have rectangular components. So this is what we are looking at. In most problems, it is useful to resolve a force into two components that are perpendicular to each other. So now what we will do is that we will draw a parallelogram to obtain the two components. But because the components are perpendicular to each other, then that parallelogram must be a rectangle, and then fx and fy are called rectangular components. So let's try to understand what rectangular components are. Alright, so I have a force F, and then I want to resolve this force along x and y. I have an angle theta with the x, I have an angle phi with the y. So I'll take my time and I'll do all of this, the two of them. Now, what are we trying to say? If I want to resolve this force, there is a parallelogram that I have to draw to contain the two components. But because these components are perpendicular to each other, I'll draw a rectangle. And so if you want to resolve the force into rectangular components, first of all, draw a rectangle to contain the force. Now, the side of the rectangle which coincides with the x-axis becomes the component of the force along the x. Similarly, the side of the rectangle which coincides with the y-axis becomes the component of the force along the y direction. Since a rectangle has opposite sides equal, fx is the same as fx, and then fy here must be the same as fy here. Now I will take the angles in turn. Alright, so let's look at this one. So what can we say? So let's consider, considering triangle OAB and using our trigonometric ratios, let's go. What can we say? Cos theta. So what is cos theta? Cos theta is OA over OB. In other words, cos theta is adjacent on hypotenuse, which is fx over f. If cos theta is fx over f, then fx can be f cos theta. Now similarly, sin theta is AB over OB. In other words, sin theta is opposite on hypotenuse, which is actually fy on f. And so if sin theta is fy on f, then I can say fy is f sin theta. Alright, so lastly, with the trigonometric ratios, tan theta will be AB on OA, and so which is opposite on adjacent, and so tan theta is nothing but fy on fx. Right, if tan theta is fy and fx, taking tan inverse of both sides, then I can say that theta equals tan inverse of fy on fx. Using the unit vector approach, I have a force fx along the I, which is the x direction, the unit vector along the x. Similarly, I have a y component fy along the j, which is the unit vector along the y direction. So that is what we have there. Finally, using Pythagoras theorem, I can say that the square of the, so f squared equals fx squared plus fy squared, basically. Now let's use the upper triangle with the phi. So considering OCB and then using our trigonometric ratio, similarly, this time around, what is cos phi? Look at this. Cos phi is OC on OB, which is adjacent on hypotenuse, which is fy on f. And so fy is f cos phi. You see that this time around, we are finding fy and we have a cosine term. What this means is that do not memorize that, oh, fx is f cos theta or whatever it is. First of all, look at the geometry before you look at what you want to do. Alright, now let's continue. Similarly, sin phi is going to be CB on OB, which is opposite on hypotenuse, and so I get sin phi to be fx on f, and so fx is now f sin phi, you see. Now tan phi is going to be CB all over OC, which is opposite on adjacent. Now you see that tan phi is fx over fy, which is opposite to tan theta, right? Then I can say that phi is tan inverse of fx on fy. So using the unit vector approach like before, I have fx along the I, which is the x direction, then I have fy along the j, which is the y direction. Finally, using Pythagoras theorem, I can say that f squared equals fx squared plus fy squared. All right, and so this is how to resolve a force along the x and y direction. In other words, what we are calling rectangular component. Thank you for watching.